Okay, to pick up where we left off, we were talking about binary compounds, and that's what your little quiz was. A binary compound just means it's made out of two substances. Okay, it can be ionic or molecular. And I'll show, we already did the ionic. We're going to work more on that today with some other compounds, but molecular means it's between two nonmetals. Ionic between a metal and a nonmetal. Okay, so when we're talking about the binary compounds, and again, binary compounds are made out of two substances. Um, they can be a metal, which forms a cation, and we talked about that, the positively charged, and a nonmetal. And the nonmetal um, would be the anion. But the other thing we didn't talk about is some of the metals, if you look at that chart that I sent you in the ions, you'll notice like some of them have a split box. Like iron. Iron can be +2 or +3. Copper can be +1 or +2. So some metals can form multiple cations. And it's usually the guys in the middle, those transition metals. They can it There's very few of them besides that, but um, they if they do form a compound, you have to say which one it is. Is it iron +2 or is it iron +3? Because it's a difference. They're different compounds. Okay. So if you have a metal and it's forming only one cation, you don't have to worry about it. You just write the name. Calcium, um, lithium, barium, whatever. Just write the name and then you write the anion and change the N to IDE. Okay. And again, we've talked about this before. On that chart I gave you, their names are written like this. But remember, if you were writing, like if hydrogen was listed first, you wouldn't write hydride, you'd write hydrogen. These are only when they're the second. But you always change the ending to IDE. Okay. That's the simplest one, and that's what you had your little quiz on. Like that one, Mg is magnesium, Br is bromide. Don't say dibromide or anything like that. It's just magnesium bromide, okay? This one, and sodium is Na, oxygen is O. Make sure you have the charges. Sodium is 1, oxygen's -2, and again, they're on that table if you printed one out. So because they don't equal each other, you're going to have to crisscross them. So it would be Na2O. Okay, again, put +1 here, -2 here. They don't equal each other. I crisscross the 2 over here. You do not have to write a 1. By writing O, you're saying there's 1. Okay, so if you're naming them, name the first one as is, the second one change the ending to IDE. If you're writing the formula, put the charges up and crisscross them. And again, this is a review of what we talked about already. Okay, so this one, if I'm going to name it, Al is aluminum, O is oxygen, but remember we changed the ending to oxide. None of this other stuff. Don't put in 3s and don't put in tris or whatever. It's just aluminum oxide, plain and simple. Okay? Don't get carried away with other, adding in dis and tris and all that. We'll talk about that later, and that's only when you have non-metals that you do that. Okay? So it's aluminum oxide. Calcium is Ca, and it's +2. Sulfur, sulfide, is S, and it's -2. They equal each other, so it would just be CaS. You don't have to write 2, 2 or whatever. If the charges equal each other, they just cancel each other out. Okay? So again, don't make it harder than it is. All right, so now I said we have these transition metals that can have more than one cation. Like copper. Copper can be +1 or +2. And you have to tell me which one it is, because copper 1 is different than copper 2. They have different masses, they have different percentages of copper, they're different substances, so it's important. Well, so how do you figure out which one it is? Well, you use what they're combined with to figure out their charge. Okay, here they say iron 3 chloride. This Roman numeral 3 is its charge. So I'd write Fe and its charge would be +3. Okay, chlorine is Cl and its charge is -1. Okay, so I got a 3 and a 1. I'm going to put the 3 over here. Don't put it straight down. You guys, this right here is not the subscript. So don't ever write Fe3. When I taught high school, I threatened to shoot my kids in the face with a Nerf gun if they did that. Don't write this as a subscript. It's the charge. Okay, so iron 3 chloride. Now, if I had this formula and I was trying to figure out the name, okay, I don't know which iron it is. It's either 2 or 3. So I look at chlorine. Chlorine's got a -1 charge. And there's 3 of them. So this side's got to be plus 3, or minus 3, excuse me. So this side's got to be plus 3. So that's why I know it's iron 3. And then I'd write that in there. So you use the back half to figure out what the front half is, okay? And you only use the Roman numerals for substances that have more than one charge. And like I said, on that table I gave you, it's a split box. You don't have to write sodium and then write a 1, because sodium's always 1. So if they only have one charge, you don't have to use Roman numerals. But if they have more than one, you have to use a Roman numeral to tell me which one it is. Okay? So again, you write the cation name and you have to figure out its charge. So you write its charge with Roman numerals. 1, 2, I think 6 is the highest, but V is 5, so VI would be 6. If you're doing 4, it'd be IV. Okay, it's like 5 minus 1. I didn't come up with the Roman numeral system, you guys. All right. And then again, you still change the ending to ID. They used to have an old way of doing it, like copper 1 was copris, and then cupric and ferrous and ferric. So the lower number was OUS and the higher number was IC. We don't have to worry about that anymore. And they use the old names too, like ferric and stannous and plum. We don't do that. All we do is this. So tin 2, tin 4, lead 2, lead 4. Okay, these are easy to figure out. This not so much. So this is what you have to worry about. Okay. All right. So if I'm going to name FeS, I know that's iron sulfide, but is it iron 2 or is it iron 3? So I look at it and I go, let me see. I'm looking at the time here, 6 minutes. Okay. Iron, I don't know, so I use this half. So sulfur is -2. So this side must be +2. Okay. They have to equal each other. So it's got to be iron 2 sulfide. Okay. When you remember, the charges have to equal 0. So use the back half to figure out what number it is. Okay. And again, you don't have to do this ferrous sulfide. It's iron 2 sulfide. And again, notice the 2 isn't right here. Don't do that. Don't make me shoot you in the face. It might be a little tough virtually, but I'll figure it out. Okay. All right. This one. This is chromium and this is chloride. Which chromium is it? Okay. Chlorine has a -1 charge and there's 3 of them. So if this side's -3, this side has to be +3. So it has to be chromium 3 chloride. Okay. Again, use the back half to figure out the charge. Okay. All right. The formula now for copper 1 oxide. The nice thing about when you have to write the formula is if you have this Roman numeral, that's its charge. You don't even have to look it up. So I'd write Cu and it's +1. And O, oxygen, is -2. So if I have Cu1 and O2, I'm going to crisscross the 2. So it's actually going to be Cu2O. Okay. Again, copper is 1, oxygen's -2. So if I crisscross them, okay. Now some people will say, okay, what's the name of that compound? You'd say copper 2 oxide. No, 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 no. Remember, this is not, the subscript is not the Roman numeral. If I want to go backwards, I'd say, okay, oxygen's -2. So this side has to be +2. 2 divided by 2 is 1. It's copper 1 oxide. Okay. So again, this subscript is used to balance them out, and it's not the Roman numeral. Okay. Tin 4 fluoride. Okay. Tin is SN and it's +4. It tells me right there. Fluorine is -1. So I have a 4 and a 1. I got to crisscross it. I got to put a 4 by the fluorine. Okay. Again, 1 here, -1 here, +4 here because it's right here. So I put the 4 on this side and I don't have to write 1. So that would be its formula. And again, it goes through all that. Okay. All right. So we are at 9 minutes. Okay. Molecular compounds are 2 nonmetals. And that's important to remember. If you have a metal and a nonmetal, you're going to have an ionic compound. You got to worry about the charges. You got to crisscross. Okay. If you have a molecular compound, you have 2 nonmetals. They don't transfer electrons. There's no ions going on. They stick together and form molecules. Okay. So when you have 2 nonmetals like oxygen and nitrogen, there's a different system for naming them. Okay. The rules are actually, it's easier to do molecular compounds because you don't have to worry about balancing out the charges. You don't have to look them up. The name basically tells you everything. Okay. You write the name of the first one as is. And this is where you're going to run into trouble because like if the first one listed as fluorine, on that chart I gave you, it'll say fluoride. Make sure you write it as fluorine. Don't change the ending to IDE unless it's the second one. And then to tell you how many you have, because you're going to have subscripts, you actually use prefixes. And I think I have them listed. And it's best if you probably write these on that naming or that periodic ion chart. But you use a prefix to tell you how many you have. And here's the prefixes. Okay. I wish I could move myself. I can't, you guys. But it's mono, di, tri. It's tetra, T-E-T-R-A, penta, P-E-N-T-A for 5. Then you got hexa, hepta, octa, nona, decade. So in other words, if you have N2, you'd write dinitrogen. I'm doing the first one now. If it has C3, you'd write tricarbon. If you have H7, you would write heptahydride, heptahydrogen. That sounds really weird, but you get the idea. So you use a prefix. And then the second one, you also use a prefix. You have to on the second one. On the first one, if there's only one, you do not have to write mono. Okay? The first one, if it's just one, if it's like CO, C is just carbon. Okay? You don't have to write monocarbon. But the second one always has to have a prefix. So if there's only one, you write mono. So CO would be carbon monoxide. Again, change the second one to IDE. But the second one always has to have a prefix. If there's only one of them, use mono. Otherwise, use whatever. Like if I had CO4, it would be carbon tetraoxide. Okay? So the second one has to have a prefix. The first one doesn't if it's only one. Okay? So P2O5. First of all, I know it's a molecular compound because I have 2 nonmetals. Okay? P is phosphorus. There's 2 of them. Diphosphorus. Okay? The second one, there's 5. So that's penta. And then it's oxygen, oxide, not oxygen, oxide. So that would be diphosphorus pentaoxide. Okay? And they go through and they go all the way through. But you can see diphosphorus, 2 phosphorus groups, penta. And you can leave the A in there if you want. It's up to you. Some people drop it, some people don't. Whatever works for you. It doesn't matter to me. Okay? But pentaoxide, 5 oxygen. And that's all you have to do. Okay, CCl4, C is carbon. And again, there's no prefix, so you don't have to do anything. Just say carbon. And then 4 is tetrachloride. Okay. And again, that tells me there's 1 carbon and 4 chlorine. That's all you have to do. How do you know again they are? If it's 2 non-metals. Okay. SO2, sulfur dioxide. Okay, dioxide. Okay. N2O you can't see over here, but N2O would be dinitrogen pentaoxide. And again, sorry, I'm in the way. I don't know which corner to go to, you guys, because I'm always in the way no matter what corner I go in. So sorry about that. Okay. Dinitrogen, 2 nitrogen, penta, 5 oxide. Okay. Now, it's 13 minutes, so we're going to practice a little. Okay, this is a one where we have more than one oxidation. Okay, so copper can be 1 or 2. 1 or 2. So we got to figure out which one it is. Chlorine's -1, and I got a 2 here, so it's -2. So this side would be +2. So it'd be copper 2 chloride. Okay. Name this one 3 carbon. So that'd be tricarbon, and then 2 would be dinitride. Okay, again, the difference between these two, this is ionic because it has a metal and a nonmetal. This is not. This is molecular because it's 2 nonmetals, but it'd be tricarbon dinitride. Okay, and again, I'm covering up. Sorry about that. Okay, this one would be iodine, and then trichloride, 3 chlorine. All right, so we'll quit right there because we're just about done. Tomorrow, or next time you go tomorrow, we'll work on polyatomic ions, okay? But make sure you have that chart run off. You really need that. And I'll talk to you soon.